All right, so one of the volunteers is going to be the person that's going to be pushed around. So decide who's going to be pushed around. The other two people are going to do the pushing. One of the things on the vector list was forces, so we're going to apply a force to one of the people. If you guys could go to the back of the room, kind of in the center of the back there's a colored tile on the floor. If the person that's going to be pushed could stand on that colored tile, that would be perfect. Now, if I were going to draw this on a piece of paper, I would put a dot on my paper where the person was starting from. So that would be my starting dot. Now what I'm going to do is I'm going to have the first person that's going to do the pushing stand behind the person getting pushed, the person standing on the colored block. And what they're going to do is they're going to push them with enough force so that they go north 4 squares. Again, if I was going to draw that, it would look like an arrow that was pointing to the north from the starting point. And again, that would be 4 squares to the north. Now, I'm hoping that Mr. Farron already put on the board with one of the dry erase markers in the second drawer an N for north up by the smart board on the whiteboard up there. And the reason is because we're going to use that throughout this particular unit. On the board over by the demo table, the whiteboard over by the demo table, that is east, so that board should have an E on it. Obviously, the other direction in the room is south and west. I think you can figure out which way is which. So anyway, what we're going to do is we're going to have the person stand on the colored block. The other person is going to push them 4 squares to the north. Now there's a third person who hasn't participated yet. I want them to go where the person is standing right now after they've been pushed 4 squares. And I want them to push 2 squares to the west. 2 squares to the west. So it should look something like this on the floor. So you have the starting point, 4 squares they got pushed initially, north. And then now from where they were, they're going to get pushed 2 squares to the west. Now, the person that got pushed, stay right where you are. What we want to do is we want to count how many squares are you from the starting point. But we don't want to go the way that you just got pushed. We want to go the most direct route possible. So on my paper, I'll draw for you a dotted line. And that dotted line is going to represent the resultant is what it's called. So I want to know how many squares, if you will. Now, if I were there and I were walking it, my foot is about the size of a square. So if I just went toe to toe and walked from the starting point all the way to where the person is standing, following that dotted line, that would tell me what the resultant was. Now the resultant is a vector. So the resultant would need 2 parts. It would need a number, and that would be the number of squares. And then it would also need the word at and a particular direction. So you would have the number of squares at, and for me right now, northwest is adequate. Okay, they aren't straight north, they aren't straight west, they're somewhere in the northwest quadrant, so that would be perfectly fine. So however many squares you guys got, that's how you would write the resultant. Now, if we were trying to do an equilibrant would be the tug of war match. So pretend that somebody was holding onto the rope, and when they were holding onto the rope, they were pulling northwest with, say, I don't know, 5 squares. I don't know what you guys got. So let's say it was 5 squares northwest. The equilibrant then would be 5 squares, the same number, at southeast. That would be the magnitude and direction that would make it so that the object wouldn't move, the flag wouldn't move in the middle. That would be called the equilibrant. Okay, and this is how you would draw the vectors on the page. Now notice when I drew them that the 4 is twice as big as the 2. It's important that everything is semi-proportional as best as you can get it. Okay, so that's how we would do that. Now, what I would like to have happen is I would like to have the person go back to the original colored starting square. So go back to the original square. And this time, instead of doing the vectors independently, what I would like to do is I would like to have both people push simultaneously. So you're going to have to count like 1, 2, 3. And remember, you're trying to push so that the first person again is pushing 4 squares to the north. The other person is pushing 2 squares to the west. And this time I want you to push concurrently, both happening at the same time. So 1, 2, 3, push. Now you should notice that the person ended up in exactly the same ending spot. No matter whether you do the vectors concurrently or whether you do them independently, the result is always the same.